So, under the title of Fighting to Load Info, I'd like to give a presentation from NF Laboratories. We have 3 researchers, and it's myself, Minakawa, and Kubokawa. 2 of us will give the presentation today. So this is the agenda for the presentation, and these are the contents to be covered. And it's since we have quite a lot of contents, I'd like to talk about LODEINFO. This is a malware. LODEINFO, if you hear this, then I think that it's known to many of you, but it's been around for about 3 years, and it's a targeted attack. It's a wrapper type that have targeted Japan, and already at JP Search and Magnica, they have come up with a report, and I think many of you continuously observe, but the malware update is aggressive, and it is often used, and so it is something, a campaign that we should pay attention to in Japan. In Hong Kong, they've done, I thought I was going to talk about the latest analysis, but from October, lots of the content have been made public, and so I don't want to overlap with what was already made public. And so rather than the incidents, I'll look at the open source investigation to make our organization robust. And so I think it can be used in other companies in general. So that's what I will talk about today. And some of the new insights on threat actor attribution is what I wish to cover today. And so these are the continuous LODEINFO campaign. And I'd like to switch to my colleague. And so this is Kubokawa, and I'll talk about the past LODEINFO campaign. And so this is the outline of LODEINFO. It's a target to Japan and often used as it's a fireless rat. And target sectors are defense sector, international politics are included, and it's delivered by attachment to spear phishing mails. And when that happens, as you see on the right, we have the Japanese decoy document in Japanese. And so LODEINFO characteristic. Internally, we have some version information, and apart from that, C2 server with the BPS hosting service is used, which is located in Japan. And malware used in the past, the similarity and TTP similarity, from that we assume that behind this is APT10. So timeline up to 2022. First, it was observed in December 2019. Version 0.1.2 was observed, and it evolved, and in about version 0.56 was observed in 2021. There had been a lot of update with additional commands, and there was obfuscations. So from here, this is the execution flow and the change of the TTP for the LODEINFO. So from 0.1.2 version, after the execution of the run DII, malicious VBA drops the DLL. And it was a low bass. And we also have the load ping. It's a good code, but you can embed the malicious code. And shell code is encrypted by a single byte XOR key, and it is implemented, and it is still being used as a shell code. And this is a CNC communication data format. We have the header and the main data, and for each they have the customized base 64, which is encoding this as contents of the data, whether it be size or the payload. They are what's included. And the payload, it's encodes by base 64, but we have the quick LZ and AES 256 is what it processes. And AES configuration This is a hard-coded per sample, and so we need to analyze this in details to find out further. For the beacon data sample, of course, we've got the header and the main data, and as was mentioned before, the custom base 64 is used, and the 3-character is substituted by easy customization. The payload itself and execution time, mix time, and RC code, the environmental condition is also included. And so the rat command in the initial state, we have the CDLS, and these are the general rat functions, and that's an assumption. And version 0 to 7, the communication format is changed. Then we had this compound script, but we could not decrypt. And so the former script will no longer work. And with 0 to 7, and the same format can be confirmed with version 032 onwards. And so what has changed in detail? The main data, the site portion, this is a payload size is XOR red. And also, the key has been added by 1 byte according to this configuration. This is version 032. We saw change in the execution flow. And RANDLL was used in execution, but from here, it's the legitimate execution file. DLL sideloading is being used, and this is used often by the Chinese APT group for a version, and sideloading is used in this version and in later versions. The version 056 C2C communication data format has changed. So before, to the true data, only base 64 was used, but for the header, we have the new encryption. So there's changes, and we need to modify the script. Beacon data, again, a small change. In principle, the collected environmental information is sent. It's the same. In addition to that, the common key for the header description or decryption is added. And also, the dummy data is added at the end, too. So, header encryption procedure, this is a flow. The main data, the end of main data, and the hard-coded key in the sample, and you have the encryption key created. And as a post parameter, we make a designation, and the script is prepared in the appendix, so please refer to it. And red command also shows some change. First, we had a command and ls, and this is the character data for the command, but now it's 2 bytes XOR red, and if you look at the code, you don't know what is being processed. From here, we look at the command as a feature, and the detection gets even more difficult.
And the summary is the decoy document is deeply created, and the C2 server are located mainly in Japan, and therefore the motivation in Japan is very high in terms of operation. And by repeating updates continuously, it is used, and there is a high potential to be continuously used. And the feature of LODEINFO is that the TTPS change frequently, and the analysis using tool and the signature matching have been continuously carried out. And since the changes take place very frequently, the IOC and signatures are used as is, but it cannot be used. So we have to continue hunting and need to catch up with the latest information. Next, I'd like to talk about research and hunting methodology. Our motivation is that for our organization, the potential threat, we'd like to counter against the potential threats and not just reading reports and that's it, but we hope that we can follow with the latest threat and we need to be motivated to keep tracking them. But it will be hard to handle the raw incidents, so we use open information and we try to get common open source information. And what we can do together with open source intelligence values from the open source IOC, we can continuously observe, and also by going deeper into the reports, we can create specific detection logics so that we can improve our defense mechanism. And we collect and share threat intelligence through Twitter and online sandbox, as well as VirusTotal. Mainly on Twitter, there are different pieces of information. And if we can get the interesting information, and the data collected from here or there based on IOC data, we can collect artifacts from VirusTotal. And to the artifacts we collected, we analyze and create yellow rules. And if we put them onto the live hunt, we'll be able to do the hunting. And the live hunt function, if you register yellow rule on a real time, you can fetch the sample that matched the rule. And if make a decision that it run properly, then as an EDR, maybe you can build it in as a detection logic so that it will work even more appropriately. And this is a flow to hunt the load info. And the DLL with the body of the load info for shellcode loader. There was a big change to the internal processes, such as version 0.3.5 with a single byte XOR decrypted and to get the shellcode easily. But with version 0.5.6, it will change a little and to do the XOR on a group level or block level, although it is a subtle change. And the blocker is simply built so that can be changed easily. So even if you understand the specific feature, you cannot get the subsequent versions easily. With 3.5, it is 1 bytes XOR, so we thought we could use brute force, but with rat command, the 2 byte XOR and there are other subtle changes. Therefore, we won't be able to take action. So it is hard to detect. So we looked for the TTP that rarely changes, and LODEINFO loader is side-loaded from default execution flow of legitimate executable, and the legitimate executable files used is from 2022, and there are only 2 observed from 2020. And rather than making changes to loader internal processes, it may be hard to change legitimate file. That was just an assumption. So we obtained all the files that may be side-loaded. And I'd like to omit the details, but as a result, if you do the detailed side-loading, the functions read is start system monitor function only. Therefore, on an export cable, the start system monitor function must be included. The DLL must be included. That is a condition. Based on this function, the VirusTotal did the search. Then, for 3 months, there are 4 files hit. If it's only 4, the rule can be operatable with the given number of detection. So we found out that it actually hit. So we did the hunting. The rule that I was talking about, the data starts from MZ, and then the functions are in the export table. And that is a raw info candidate that we did the hunting. It was simple, but up to version 1.4, it could be Han. So you hunt the sample and analyze and be able to accumulate the insights gained. But if you want to do that manually, it may be painful. So we semi-automated it. I'd like to talk about the flow. In the case cluster, the Kalon draws and on a regular basis from the BIOS total, the samples obtained and store them on the F3 storage. F3 storage stored and using the sample Kaku or IBM Python used to automatically analyze. And it is still inefficient, then we manually analyze them. The insight gain, the open source CTI accumulate these insights to achieve this flow. And using open CTI, the continuous research and also the correlation based on the large volume of data and the external link or external reports, as well as malware body information and the indicator and attack patterns and other pieces of information can be related to each other. And graphically, there's a function to show graphically, and it may be helpful for correlation analysis as well. A free sandbox can do many different things, but because of the time limitation, I am not going to cover that, so please refer to that later. Now, we did the LODEINFO after 2022, and I'd like to talk about the change of TTPS that was observed. 2022 timeline is as follows. At the spear phishing is studied and the initial access and also the target sector did not change drastically. The big change though is the site loading and exit change for site loading, the K7.exe, so that the detection became a little more difficult. And the LODEINFO malware in 2022, there was almost no change, but the big change is on the execution info. So more focus on the avoidance of detection.
So a CNC server hosting information trend is the same, and so the IP geolocation is Japan, Volta, Linode, but these are not affected by takedown. From here, I'll talk about the details. In 2022, changes were seen, and these are some of the highlights. In 2022, in March, and it was 059, the changes there. Not a big transaction, but shellcode analysis, API, you get from hash, and then you get the address. That's what malware does. But JSHash was changed. Algorithm. On the right, you see the return. We have the 2-byte XO, and that is specific to sample. And the analysts do this from hash. You get the Windows API, and without this key, you cannot work this. So that's a cumbersome process. So 062 was observed in April, and there were additional functions. The version in the olden days, if we tried to attach the version, but memory bugged, and this version, the version information now comes at the end. And so this is a major implementation. LODEINFO RAT, the memory command, there was additional feature. It now supports 64-bit shell code. It used to be 32. So recognition scope has broadened. It's a very useful additional feature. And so 062 show with the phase-wise locale environmental check. It's the same version, but we see this gradual change. There used to not be a locale check, but if it is JP locale, then you have to have this to operate this. maybe it had become stringent, and so now it will only move if it's NUS, and so the routes have been changed, and it's the same version, but we said it's not exactly the same, so version control is mismanaged. At least we saw a glimpse of that. Next, in June, 063 was observed. Here, the command had been increasing with additional feature, but we had a command decrease from 21 to 11. But I think they organize these unused commands. This version, a major change is the execution flow, and load info in principle from VB macro. You get the load info and it was deployed in the memory, but now it changed to SFX. It's a self-response, and so it's not the macro. So maybe they changed this to correspond to that. And also, we have the binary OS, the blob. The load info is stuck, and you load from there. It's and JSAC also showed this pattern, which is more frequently seen. With DLL, if there's a load info, then you detect people who are writing this can go through this trap. And so I think we were able to capture this with our methodology. So version 065, and the report did not show the details, and there was not a big change, but the locale check, the sleep was added technically, and the process itself. And it continues to calculate, and so sandbox without a lot of resource. I think it stops right here. But Kaspersky said that execution has changed, and the shellcode to VBA in the tool to make into shellcode, and the VBA downloader was created. That's the flow change. But this is an old tool, so maybe it can be detected. And so the new execution flow, according to Kaspersky, it looks like this. And in the downloader in the memory in the middle, bring the 1155, and the load info is brought here and is executed. But the load info, the persistence of load info, they usually side loading, and so you have to make persistent the original exe. The MSI exe is invoked and it does not operate properly. And so, although they created this, it is not persistent. And I think it was just a one-time spur of a moment thing. And so the load info that we analyzed is so far, but they have continued to avert the detection. So I think that the TTPs will change in the future and will continue to do so. And so from here, we'll talk about go into the insights of the threat actor. So we've been talking about the TTP changes. We paid attention to version 063 and the changes when this was relocated. We have the legitimate executable and the DLL shellcode loader and encrypted blob, frequently used by the Chinese APT groups. Particularly, you have the set of 3, and APT10 cases which were reported before was very similar to this.
So it changed the LAN, so it's almost the same, and I researched. And the way deco file is made, the load info is skipping some of the steps, so sometimes from the design it is similar, so we deeply investigated the decoy file. And we investigated the deco file, and the deco file, the load info deco file that we discovered, there are 3, and on the left, these are from decor file, or maybe there's some that came along with decor file. And the timestamp, and also based on the surface information of decor file, we extracted the information. The DLL submission time on the left-hand side, this is submission time, and also the compile time are deviating with each other. However, the decor file, after being created in a day or two, it is already submitted to VT. Therefore, it shows a very realistic time. And if you look at it more carefully, on weekdays during the daytime, where people are working, it is concentrated on the timeline. So the decor line is no touch. So we decided to go deep into the surface information. And as we investigate the surface information, the deblock reader is used and the general user names used. So there are multiple people. But what we focused on is what Windows user says. And why did we focus on Windows users? Because the Office 365 and 2019, and if you create a document file, you can tell that as initial value, that device username is there. And this kind of information is there. And we haven't looked at it, and it was quite rare. And it is rare, therefore we wondered, and we searched on VT how many of them we have. And it was about 30 in 3 months, or only less than 100 in 6 months. So as a I think this was rather rare. And what is a kind of environment that we have these surface information? And according to our research office, 2016 and older, only the Japanese versions have something like this. And then the LODEINFO version 6.3 and the TTP did some tiles, and old version, old TTP technique, tried, and maybe it proved from old days. And AV scan, the VTAV scan, and it was judged as malicious. Then there are two, and one may be false positive, so we could improve clearly. But anyway, what we can say is old office environment to create decoy document is very rare. If you research further on, as mentioned earlier, APT10 decor file detected, and we thought that was doubtful. So we researched even deeper. And for the past APT reports and the VT query use, and we looked for the surface information with the Windows user, but there was only one false positive, and there are other 13 potential false positive, and as a matter of fact, we found 11. And the creation time shown in 2017 and in the beginning of 2018, and maybe it was used with 2016 Office environment. The file name 1.x. At the time of loading, for decor file names are used, so the naming convention is also in alignment. As a result, we researched everything with APT operation. The decor file was used for APT10 operation. And the LODEINFO and APT10, we cannot insist they are the same, but maybe there's some overlaps of the people and the user used to use in the environment, and maybe they were reused. And that's what we understand with confidence, with model-like confidence. And we created diamond model based on the information and the social on a y-axis, and LODEINFO has the motivation and also side loading and Japanese decoy as well. And the past APT10 operation diamond model compare, and we thought it was reasonable. And another thing that I'd like to talk about at the JSAC, it will be elaborated, so I'm not going to talk too much details. But in 2022, there was an instruction target email, and also loading, other than loading for the Operation Westy link. Last May, it was opened by entity, Docomo. And what I thought was interesting, JCLAT report, with SPD, the loading for information is used to pretending. And we also observe similar things, and loading for the foundation are targeted quite so often. So we are looking at impersonation data, and the method was not observed, but these two organizations are impersonated. So there are two alerts and two impersonate, meaning that they are targeting the people who are interested in organization. The people who are interested in these organizations are considered as the economy circle. And if you're interested in operation and law sector, maybe there are similarities. And diamond model compared. The left is loading for that we created. The right is operation vested in entity security created, and we drew that. And red is commonalities. And the specific fields such as capability and other items says the custom is not used, and there's some inconsistencies, but abstract social and technique axis, they say think tank, but they're related to diplomat or economic interest group. And therefore, the technique to achieve this is ELL sideloading or spear phishing and geolocation technique used. What I'd like to mention is that these two attributes are they completely the same. We don't have enough information to discuss that, but what we can say is the trend of 2022 is that the targeted trend shows that it seems like they have information and also using technique. Maybe computer has some ideas and there are commonalities. So starting from emails, the targeted attack from email needs to protect these techniques. Lastly, I'd like to talk about a limitation of the research and conclusion. As mentioned, we are based on open source and have engaged in different activities, but the samples are posted on the internet. So we tend to be reactive, and the samples are submitted on VT, and the contexts are lost, and there are no file names. Therefore, we tend to have dot information. Therefore, using external intelligence and human connection to connect the dot into lines to look at the entire operation. Otherwise, the open source will be difficult to do the analysis of commonalities. And changing the subject a little, the challenge of takedown. Ideally, if we hunt the sample and if we research IP and if we do the takedown, even if there is someone who did the loading info, we could have stopped. But I submit our views, but they don't take any action, so realistically it would be hard. And there was some case of interactions, but still was not taken down, so it is quite impossible.
事業者が対応してくれないよねって話だ。
And so we say that the partners will not take action, but if they are active, would it work? Well, they say that 99.9%, unless it's coming and then you can prove it, they will not help. But it's not like phishing. And the server of LODEINFO in the third party's eye is difficult to prove. And so you need a long-term communication. That still is an issue. And so can we take down and defend within a practical time? I don't think so. That's my personal viewpoint. And then, having said that, the LODEINFO threat, what can we do against them? And what can we do as business, a company? So you see the sliding scale of the cyber attack on cybersecurity, and the operation of the security is more mature the farthest right you go. But offenses are not possible. And so what can you do? Intelligence, it should be utilized, and the activities we will continue to do, collecting information and come up with the adequate solution. And the corporations must be well equipped so that they can block these targeted attacks against Japan. So we need these appropriate actions for these 4 pillars. So, app blocker, and I will skip this because it was covered in the first presentation. But these are some of the blocking methods that you can refer to. So the LODEINFO, we shared about the information on the recent TTPS and insights. And based on open source, we did research, and I think it can be utilized by different corporations. So what you can do, we will share this information with you through these activities. We need to build up an organization, which I think that many businesses are looking into. And although we have to always catch up, but we will take these actions to make sure that we can lessen the number of targeted attacks for Japan. So, talked about the composite scripts. We have the version 065. Those which are not in the VT, if you are interested, then please refer to that. That concludes our presentation. Thank you very much for your kind attention.